Good evening, students. Today's new topic, the coordination compound, the class 1 or the first period. So, the first I can discuss what? Introduction. First I can discuss what? Introduction. So, here, what is coordination compound? These coordination compounds are also called metal complex, or it is a metal complex, or simply we can say it is a complex, or it is the complexes. These coordination compounds, they are also nothing but a inorganic salt. It is a inorganic salt. Okay, so this is the inorganic salt, and the coordination compounds are found in living and non-living system. Living and non-living system. Okay. Coordination compounds are found in living and what? Non-living system. So for example, the living systems are hemoglobin. Yes, hemoglobin. So hemoglobin is a metal complex and it contains iron as a central atom, and it is a iron containing protein. Okay, this is the iron containing protein. It is a hemoglobin is iron containing protein is an example of what? Coordination compound. The next is what? Chlorophyll. Next is what? Chlorophyll. Yes, this chlorophyll is a magnesium complex which is present in what? Which is present in what? This is a pigment which is present in what? Chlorophyll is a pigment which is present in what? Green plant. And the next is what here? Vitamin B12. Vitamin B12, or it is also called cyanocobalamin. It is also called vitamin B12 is also called cyanocobalamin. The central metal atom is what? Cobalt. So this is the importance or the uses of what? Coordination compound. The next is what here? The next is the non-living system. Even though these coordination compounds are used in what? Many metallurgical process. And also industrial catalyst. And next it is used in what? It is used in what? Analytical reagents. In the analytical reagents. So this is what introduction about the coordination compound. Okay. So the next is what here? Now I can go for what? Double salt and complex salt. Now I can go for what? Double salt and what? Complex salt. Now I can go for double salt and what? Complex salt. Double salt and complex salt. Okay. So here now I can discuss one by one. Double salt. What is this double salt? The question. The double salt. So now I can write double salt. Yes, the double salt is made up of what? And it is made up of what? It is made up of two simple salt. It is made up of two simple salt. Okay, it is made up of two simple salt. Okay, so they dissociate into what? They dissociate into what? Simple ion. They dissociate into simple ion when dissolved in water. So what are the double salt? The double salts are made up of what? Two simple salt. When they dissociate or they break down into what? Their constituent when dissolved in water or any other solvent, so it is a double salt. And it is a molecular compound. It is a molecular compound. Exists only in what? Exists only in what? Only in solid state. Exists only in what? Solid state. So this is about what? This is about what? Double salt. So example, one by one I can discuss. Example, the first is what? Potash alum. This is the potash alum. This is the double salt, potash alum. So what is the formula? Potash alum. Potash alum is K2SO4. Okay, Al2SO4 thrice. Al2SO4 thrice. The next is what here? The next is what here? 24. This is what here? 24H2O. So this is the example of what? Double salt. The double salt is made up of two simple salt. K2SO4 is one simple salt. Al2SO4 or thrice is one simple salt. Simple salt plus simple salt is equals to what? Is equals to what? Double salt. The next is what? The second example, shortly we can say FAS. What is this FAS? It is nothing but a ferrous ammonium sulfate. What is this? Ferrous ammonium sulfate. The ferrous ammonium sulfate is the second example of what? Double salt. What is the formula? Formula is what? FeSO4, NH4 twice, SO4, and it is what? 6H2O. So this is the second example of what? Double salt. It is made up of two simple salt. FeSO4 is one simple salt. NH4 times SO4 is one simple salt. Simple salt plus simple salt is equals to double salt. So even though this FAS is also called what? Morse salt. It is also called what? Morse salt. And the third example is what? The third example is cornelite. The third example is what? Cornelite. So this is nothing but a KCl. This is what? MgCl2 and 6H2O. So this is also made up of two simple salt, KCl and MgCl2. So these are the examples of what? Double salt. So here it means the double salts are made up of what? Two simple salt, and they dissociate into it gives what? Simple ions when dissolved in water, and these are the molecular compounds exist in what? Solid state. Even though the constituent or ions, constituent of what? Double salt, the constituent of what? Double salt or ions retains individual identity. Retains what? Individual identities. So this is about what? This is about what? Double salt. So next I can go for complex salt. Next I can go for what? Complex salt, or it is also called coordination compound. So what is this complex salt? Okay, first I can go for what? Example. Later I can discuss what? Importance. Okay. Now next is the complex salt. First is the double salt. The second is what? Complex salt. Complex salt is nothing but a coordination compound. So in this, what is this complex salt? So it retains its identities. It retains its identities both in solid state and when dissolved in water. Okay. So here whatever this actually double salts are what? They exist only in the solid state, but they exist in both in solid state as well as when dissolved in water or any other solvent. So it is the complex salt. So here now I can see here the example for this complex salt K4. Now I can write FeCN6. K4 and FeCN6 is an example of what? Complex salt. Okay, here what happens? So the double salt, they dissociate into simple ions when dissolved in water, but they not dissociate into what? They not dissociate into ions. For example, when K4 FeCN6 is dissolved in water, it not gives Fe plus 2 and what? Cn minus. It not gives Fe plus 2 and Cn minus. Not gives. So it means lost their identity. So the ions or the constituent of this complex salt lost their identity. In case of double salt, they retains identity. Here is lost their identity. Double salt exists in solid state, but it retains identity both in solid state when when it is dissolved in water. So it not dissociated, it gives ions. When K4FeCN6 is dissolved in water, it not gives Fe+2 or Cn minus. So this is what a complex salt. But here in this complex salt, you must know what is this Fe. Fe is called what? Iron. Iron is called central atom. Iron is called central atom. Iron is called central atom. So Cn is called what? Ions. It is a group of ion. Ions is nothing but a ligands. So C is called what? Cn. Cn is called what? Coordination number. So this is it means the coordination compound is also called what? Metal complex, because it contains the metal as a central atom or ion. So it is called what? Complex salt. So finally, what is this double salt and simple salt? I can discuss. So both double salt and the simple salt, both double salt and simple salt formed by the combination of two or more stable compounds in a stoichiometric ratio. So it is called what? Double salt. What is the double salt and the complex salt? Sorry, what is double salt and complex salts? Okay, the double salt and the complex salt. Okay, the double salt or the complex salts are formed by the combination of two or more stable compounds in a stoichiometric ratio. So it is called what? Complex salt. Now I can go for the definitions and terminology which is used in what? Coordination compound. Okay. So now the first I can go for coordination entity. So I can go for whatever coordination entities. Okay. So the first, now go for one by one definition. What is the definition of coordination entity? Central metal atom and ligand. First is the definition of first coordination entity. Okay. What is this coordination entity? Coordination entity. The coordination entity. First I can give example. CONH3 and this is what? Cl3, and next is what? NiCO4. So these are the examples of coordination entity. What is this coordination entity? Here the cobalt ion, which is surrounded by what? 3 ammonia molecule and 3 chloride ions, where the nickel is surrounded by what? The 4 CO molecules. So it is the coordination entity. How can you define coordination entity? Coordination entity consists of central metal or ion, and bonded with what? A fixed number, and bonded with a fixed number of ions. Fixed number of what? Ions or molecule. Fixed number of ions or molecule. Fixed number of ions or molecule. So it is called what? Coordination entity. The examination, one more question. What is the coordination entity? The coordination entity consists of central metal ion, and we had bonded or surrounded by with a fixed number of what? Ions or molecule. This fixed number of ions or molecule, so we can call it as ligands. Where in a coordination entity, the cobalt central atom and surrounded by what? The molecules like what? Ammonia, and the ions like what? Chloride. So this is called what? Coordination entity. So, okay, this is the first definition. So, this is the coordination entity is over. So, in the coordination entity, so this is the example where the cobalt ion surrounded by what? 3 ammonium molecule and 3 chloride. In the second example, the central atom nickel is surrounded by what? The 4 carbon monoxide molecule. So, it is called what? Coordination entity. So, now I can go for the second one. Now I can go for what? The second one. What is the second one here? The second one I can discuss here. First one is what? Coordination entity. Second is central atom. Next is the central atom, central metal atom, or in some book has given central metal ion, central atom or central ion. So what is the central ion or central metal? In a coordination entity, okay, in a coordination entity. So what happens here? The central atom or ion bond with what? Bond with fixed number of what? Fixed number of what? Ions. Fixed number of ions are groups. Fixed number of ions are groups. So it is called central atom, or it is also called central metal ion. So how can you define the central metal atom or ion? In coordination entity, the central atom is bound with a fixed number of ions or groups. This fixed number of ions or groups is nothing but a ligands. So example. Now I can go for example. Example here CO. This is what NH3 and this is what Cl3. So which is the central metal atom here? The cobalt is the central metal atom. So what is the oxidation state? +3. This is the central metal atom. I can go for second example. K4. This is what FeCN6. K4, FeCN6. Is it correct or not? So which is the central metal atom here? The central metal atom is Fe+2. Central metal atom is what? Fe+2. So this is the thing. And the position is or it is located at what? Central position. So it is called central metal atom or central ion. Okay. So this is the coordinate central metal atom. So the next, the first definition is coordination entity. The second definition is what? Central atom. The very important is now I can discuss, that is what? Ligands. Now is the ligands. So what is the ligands? Now I can discuss what are ligands. One more question. So the ligands are ions are molecule. Ligands are ions are molecule. Ligands are a group of ions are molecule. So which can donate a pair of electron. Which can donate a pair of electron to what? A pair of electron to central ion or central atom. So it is called what? Ligand. So in the examination, one more question. What are ligands? Ligands are the ions or the molecules, so which can donate a pair of electron to the central atom or central ion. So it is called what? It is called what? Ligands. So here, even though one more definition. So ions are molecule. Ions are molecule bonded to what? Bonded to what? Central atom. Bonded to central atom. Central atom. So ions are molecule bonded to central atom in a coordination entity. In a coordination entity is called. In a coordination entity is called what? Is called what? Is called ligand. Is called what? Is called what? Ligand. In the examination, one more question. What are ligands? You write ligands are the ions are the molecules which can donate a pair of electron to the central atom, or ions are the molecules so when directly bonded to what? The central atom in a coordination entity is called what? Ligands. Even though these ligands are called what? These ligands are called what? Lewis base. These ligands are called what? Lewis base. You know that in physics first year we have studied what is meant by Lewis base. Which gives electron is called Lewis base. Here the ligand gives electron, so it is called Lewis base. And the next is what here? The central atom. the central atom or ion, it is called what? It is called what? Lewis acid. It is called what? Lewis acid. So this is a ligands. Now further I can go for the classification of what? Ligands. Classification of ligands. Now ligands definition is over. Now classification of ligands. Very important. Classification of ligands. Classification of what? Ligands. Three types of ligands are there. One is monodentate ligand. Okay, this is monodentate ligand. The second is bidentate ligand. And the third one is what? Polydentate ligand. Okay, polydentate ligand. So these are the three types of what? Ligands. The first I can discuss monodentate ligand. First I can discuss what? Monodentate ligand. So here, what is a monodentate ligand? The examination, one mark question. The ligand, okay, this is the ligand which can donate only one pair of electron, one pair of electron to central atom. So it is called what? Monodentate ligand. In the examination, one mark question. What are monodentate ligands? These are the ligands which can donate only one pair of electron to the central atom, or in some book has given like. So here, and it has one donor atom, and coordinates central atom at one position is called what? Monodentate ligand. So which can donate only one pair of electron to central atom, or it has one donor atom, and it coordinates central atom at one position, so it is called monodentate ligand. So what are the examples of monodentate ligand? First it is water, second is ammonia, third is carbon monoxide, next fourth is chloride, fifth is bromide, next is what? Fluoride. So this is the next, even though we can write this pyridine, so this is also, so these are the monodentate ligand. So here oxygen is the donor, one donor, here nitrogen is donor, here oxygen is donor, here chloride is the donor, here bromide ion is donor, here fluoride ion is donor. So water has one donor, so it is monodentate. Ammonia has nitrogen donor, so it is a monodentate. Here in the carbon monoxide, oxygen is the donor atom, so only one donor atom, so it is called monodentate ligand. So these four are called neutral ligands. These are the neutral ligands, and these are the negative ligands. In the examination, one more question. So give an example of neutral monodentate ligand. So out of these, anyone you have to write down, or write or give an example of what negative monodentate ligand. You write chloride, bromide, or fluoride. So this is a monodentate ligand. So this is a monodentate ligand is over. Now I can go for bidentate ligand. Okay, what is this bidentate ligand? Very important question. So what is this bidentate ligand? Okay, I can discuss bidentate ligand. So here, what is this bidentate ligand? Yes. So yes, bidentate ligand. Okay, bidentate ligand. First is orodentate ligand. The second is bidentate ligand. So what is the bidentate ligand? Which can donate two pairs of electron, not only two pairs of what? Electron. Which can donate two pairs of what? Electron. To what? To central atom, or to central atom. So it is called what? bidentate ligand. What is this examination? One more question. What are bidentate ligand? The ligands which can donate two pairs of electron to the central atom. Or suppose it has two donor. It has two donor atom. It has two donor atom and coordinates central atom at two position. So at two position, so it is called what? Bidentate ligand. Okay, so what are the examples of bidentate ligand? Very important. First example. So ethane 1,2 diamine. Ethane 1,2 diamine, or it is also called ethylene diamine. It is also called ethylene diamine, and so we can use this is the En. So it indicates what? Bidentate ligand. So ethane 1,2 diamine. What is the formula? What is the structure? So this is the CS2, and this is what? NS2, and this is what? NS2. So what is this, anybody? So it is a ethylene diamine. So how many donors are here? One nitrogen and two nitrogen. Total two donor atoms are there. So hence it is called bidentate ligand. Ethane 1,2 diamine or ethylene diamine. Shortly we can write En. It indicates what? Ethylene diamine. How many donors are here? Total how many donors are? Nitrogen is one donor, and this nitrogen is also one donor. Two donors. So hence it is called two donor. Hence it is called what? Bidentate ligand. It is called what? Bidentate ligand. So the next example is oxalate. Next is the oxalate ion. What is the formula? C2O4 minus 2. C2O4 minus 2. What is the structure? The structure is CO, and next is CO. This is minus. So this is one donor, and this is one donor. So in case of ethylene diamine, two nitrogen donor. So it is bidentate. In case of oxalate ion, two oxygen donor. So hence it is called what? Bidentate ligand. This is second example. Now I can go for third and fourth example. So I can go for third and fourth example. Okay. So here I can write here. First example ethylene diamine. Second example oxalate. So we can write OX. But the third example third is dimethyl glyoxime. Shortly it is called DMZ. What is this formula? CS3C, and it is what? CS3. Now it is a double bond NOH. Now it is double bond. This is NOH. So how many donors are here? Two donor. Nitrogen is one donor. The next is the fourth example. Glycinate ion. What is this? Glycinate ion. So we can write GLY is the glycinate ion. DMZ dimethyl glyoxime. En ethylene diamine. OX oxalate. So what is this glycinate ion? So we can write here. This is the CH2, and next it is what? NH2, and this is COO minus. How many donors? Two donor. Nitrogen is one donor, and oxygen is one donor. Total donor atoms are 2. So hence it is called what? Bidentate ligand. So here the glycinate is a negative bidentate ligand. Oxalate is a negative bidentate ligand. DMZ and ethylene diamine is a neutral bidentate ligand. Okay, this is the bidentate ligand is one. Monodentate and the bidentate ligands are one. Now I can discuss polydentate ligand. Next I can discuss what? Polydentate ligand. So here, first I can write, okay, third one. First one is monodentate, second one is bidentate, third one is polydentate ligand. So next is the polydentate ligand. Yes, in this polydentate ligand, so it has more than two donor atom, more than two donor atom. It has more than two donor atoms. So it is called what? Polydentate ligand. So these polydentate ligands are further classified into tridentate ligand. What is this? Tridentate ligand. Tridentate ligand. Yes. What is this tridentate ligand? So what is a tridentate ligand? Which can donate 3 pairs of electron. Which can donate 3 pairs of electron to central atom. Which can donate what? 3 pairs of electron to central atom. So it is a tridentate ligand. Okay, is it correct? Now otherwise, one more definition. It has 3 donor. It has 3 donor and coordinates central atom simultaneously at 3 position. In the examination, what is a tridentate ligand? The tridentate ligand which can donate 3 pairs of electron to central atom. It is correct. Otherwise, this tridentate ligand, it has a 3 donor atom and it coordinates to the central atom through coordinate bond simultaneously at the 3 position. So it is called what? Tridentate ligand. Example. So example for tridentate ligand, I can write here diethylene. What is the name? Diethylene triamine. Diethylene triamine. So shortly we can write tri-en. What is this, everybody? Tri-en. Okay. Sorry, not tri-en, di-en. So it is nothing but a di-en. Di means diethylene. So diethylene triamine. Okay, di-en. So I can write the structure of diethylene triamine. Okay. First I can write here. Okay. NH2. Next is what? CS2. Next is what? CS2. Next it is what? NH. Next is what? CS2. Next it is what? CS2. Next it is what? NH2. Okay. So here tridentate ligand has how many donor atom? 3 donor atom. Example is diethylene triamine. Triamine means, so this is one donor. This is the second donor. This is the third donor. How many donors are there? One donor, second donor and third donor. How many donor atoms are here? 3 donor atoms. So that's why it is called tridentate ligand. Example is diethylene. Diethylene means how many CH2s are there? 2 CH2. Diethylene, how many amines groups are there? 3. So that's why it is called tridentate ligand. So the next is what here? A is what? Tridentate. Now I can discuss tetradentate ligand. What is this, anybody? Tetradentate ligand. Tetradentate ligand. Okay. So tetradentate ligand. So polydentates are classified into tri, tetra and hexa. So what is this tetradentate ligand? Example. What is this tetradentate ligand? Okay. So I can discuss. What is this tetradentate ligand? Same. So the tetradentate ligands which can donate how many pairs of electron? Which can donate 4 pairs of electron to central atom. Or it has how many donor atoms? Anybody? It has 4 donor atoms. 4 donor atom. Okay, and coordinates central atom simultaneously at how many? At 4 position. So it is called what? Tetradentate ligand. So what are the examples of tetradentate ligand? So the first I can write example is nothing but diethylene. Okay, triethylene. Now I can write triethylene tetramine. tetraamine. Triethylene tetraamine. So shortly we can write tri-en. Shortly we can write tri-en. So now this is the example of what? Tetradentate ligand. So I can write the structure. So while writing the structure, so we can understand clearly how the electrons donates, how the ligands or donor atoms gives electron to the central atom. So example is what? Triethylene tetraamine. Okay, first I can write NH2. This is CH2. This is what? CS2. Next NH. Now it is what? CS2. Next it is what? CS2. Okay. And next is what here? The next one more example is NH. Okay. CS2. CS2. Okay. I can write here. Better I can write here NH. Now it is what? CS2. CS2. This is what? NH2. Is it correct or not? Yes. What is the name? Triethylene. Triethylene. How many ethylene? 1, 2, ethylene 2 and 3. This is triethylene. How many amines? Tetraamines. 1 amine, second amine, third amine and fourth amine. How many donors are here? First donor, second donor. This is what? Third donor. It is NH. The third donor. This is the third donor. This is fourth donor. Total how many donor atoms? 4 donor atoms. All the 4 donor atoms are nitrogen. So hence it is a tetradentate ligand. So it is a tetradentate ligand. How many coordinate it forms? This triethylene tetraamine, it forms how many coordinate bonds? 4 coordinate bonds. So hence it is called a tetradentate ligand. So the last one is I can discuss, that is what? Hexadentate ligand. What is this, anybody? Hexadentate ligand. Same. Now is the last one is what? Hexadentate ligand. Last one is hexadentate ligand. Yes, hexadentate ligand. So what is this hexadentate ligand? Okay, what is this hexadentate ligand? Yes, here also same. What is the hexadentate ligand? Which can donate? Same, 6 pairs of electron. Which can donate 6 pairs of electron to central atom. Or it has how many donor atoms? It has 6 donor atom. It has 6 donor atom and coordinate central atom simultaneously at 6th position. At what? 6th position. So it is called what? Hexadentate ligand. The next is what here? Example. Next example is what? EDTA. Shortly we can say EDTA. What is this EDTA? Now it is ethylene diamine. Ethylene diamine. Next is what? Tetraacetic acid. Okay. So I can write here. So what are hexadentate ligands? The ligands which can donate 6 pairs of electron to central atom, or it has how many donor atoms? 6 donor atom and coordinates for central atom simultaneously at 6 position. So it is called hexadentate ligand. So example is EDTA. So what is EDTA? Ethylene diamine tetraacetic acid. So it is a okay. Now I can write the structure. Ethylene. Yes, first you have to write ethylene group CS2. This is ethylene. Next diamine. Here is 1 nitrogen. Here is 1 nitrogen. So this is tetraacetic acid. This is what? CS2. This is what? COH. Next is what? CS2. This is what? COH. Next is what here? Next is what? CS2. Next is what? COOH. Next is what? CH2. COOH. So this is what? Ethylene diamine tetraacetic acid. In some book we can tetraacetic acid. Okay, EDT, ethylene diamine tetraacetic acid. This is the formula. But tetraacetate ion, suppose if it is a tetraacetate ion, tetraacetate ion, it is also called ethylene diamine tetraacetate ion. Means you have to remove H minus H, it becomes what? Minus. Minus is a ion, acetate ion. Minus. This is what? Minus. So here I can ask one question. How many donors are here? 6 donors. Nitrogen 1, nitrogen 2, oxygen 3, oxygen 4, oxygen 5, oxygen 6. Total donor atoms are 6. How many donors? Nitrogens are 2 and oxygens are 4. Total donor atoms are 6. Hence it is called what? Hexadentate ligand. So these are the classification of ligands. First is monodentate, second is bidentate, next is the polydentate. In this polydentate further tridentate, tetradentate and hexadentate with examples are over. Yes, now special types of ligands I can discuss. Ambidentate. Ambidentate ligand. So before going to this discussion about ambidentate ligand, so first I can give example. This is CN. CN is a monodentate ligand. Suppose here in a cyanide ligand, if carbon donates or bonded to central atom, so it is read as cyanide complex. Next is what here in this monodentate ligand cyanide. Okay, suppose if nitrogen, okay, it is not necessary. Okay, this nitrogen bonded to central atom, so it is read as isocyanide. It is read as isocyanide. Is it correct? Yes. Same example I can take. NO2. This is called nitro. If nitrogen bonded to central atom, so it is read as nitro. So suppose ONO, so this is also nitro. If it gives oxygen, if oxygen is the donor, so it is read as nitrite 2, HCl. Cyanide is a monodentate ligand. If carbon is directly bonded to metal or central atom, or carbon is the donor, it is a cyanide. If nitrogen is the donor atom or the nitrogen donates an electron to central atom, it is this complex is called isocyanide complex. Similarly, if nitrogen is donor, it is a nitro complex. If oxygen is the donor, it is a nitrito complex. What is the ambidentate ligand? The ambidentate ligand means the ligand it has two donor. No doubt, cyanide. Nitrogen is donor, carbon is donor, but only one can donate electron to central atom. Both carbon and nitrogen not gives electron simultaneously. If nitrogen gives, carbon will stop giving electron. If carbon gives electron to the central metal atom, so nitrogen will stop what? The giving electron. It means, so it is a monodentate. It has two donor atom, but only one can donate what? A pair of electron to the central metal atom at a time. At a time, only one donor donates what electron to the central atom, so it is called what? Ambidentate. In the examination, what is the ambidentate ligand? The ambidentate ligand, it has two donor, but only one can donate a pair of electron to the central atom, so it is called what? It is called what? Ambidentate ligand. So another ambidentate ligand is, we can write this as CN, and it is also what? This is thiocyanate or isothiocyanate. So these are the examples of what? Ambidentate ligand. So the last I can discuss the chelating ligand. The last one is the chelating ligand. Yes. What is this chelating ligand? Now I can write here chelating ligand. What is this chelating ligand? So here in this chelating ligand, chelates means ring formation. So here what are the chelating ligands? Bidentate or polydentate. Polydentate means more than two donor. Bidentate are the polydentate ligands. Ligands coordinates a central atom. Coordinates what? Or bonded with what? Central atom, forms a ring-like structure. Forms a ring structure. A ring-like structure. So it is called chelating ligands. Example. So what is the chelating ligand? The bidentate or the polydentate ligands, they coordinate a central atom forming a what? form a ring structure. So it is called chelating ligand. One more example I can discuss. So ethylene diamine, already we have discussed, it is a bidentate ligand. It has how many donor atom? 2 donor atom. Both the donor atoms are nitrogen. Which is the central atom? Central atom is copper. Here one more ligand. This is what? CH2. This is what everybody? CH2. So the donor atom is nitrogen. Here the donor atom is nitrogen. So okay. So now I can write here. So okay, now here the nitrogen it gives electron, and here this nitrogen gives not hydrogen but the nitrogen it gives electron. Okay, I can write like this. N is to understand NH2, and now I can write here this is what? NH2. Okay, so here the nitrogen is the donor, here nitrogen is the donor, here nitrogen is the donor. So hence it is what everybody? It is called what? Chelate. It is called what? Chelate. What are the chelates? If you use bidentate or the polydentate ligands or bonded to central atom or coordinated to central atom, it forms a ring-like structure. So this is called what? Chelatic ligand. So this is the already we have discussed what? Some definitions and the terminology. So tomorrow I will continue since the second class. So what is meant by coordination sphere and polyhedron and the coordination compound. Sorry, coordination number.